In the JavaScript project Electric Dreams, the final stage is to bring it all together and incorporate the logic into the program flow. So we have a lot of these parts that were present in the previous versions. So we had our basic responses that would be asked. We were able to get all of our elements that are on the page. So those elements correspond to the HTML elements that are here. So we have a computer paragraph input for human. We have our enter button. So these elements are going to have their contents modified or changed depending on what is happening inside the program. The human will keep inputting. Computer will keep updating its content. Now, focus just simply makes when the page loads, it puts the focus on the input field so that it will be ready for someone to type the moment the page loads. That's considered a nice to have. It's not a must have, but from a usability standpoint, it's nice when you go to the page and the form is prompting you to start typing that in so you don't have to click on it or tab to that input field before you can start entering in content. Event listeners I've covered previously. The play game function is where the real core logic of our program is occurring. Now, one of the things that's happening here as we look at this is we have inside of play game, we have to take the input and convert it to lowercase. That allows us to be able to analyze it without having to analyze upper and lowercase variations of input. And that's really critical because otherwise, on a simple two-letter word, we would have to look for all lowercase, all uppercase, and then a version where the first letter is uppercase, the second letter is lowercase, and a version where the first letter is lowercase, the second letter is uppercase. If we had to do that for longer answers, that would really suck and be near impossible to code. So it makes more sense to render the input into a single case because the case sensitivity is not critical for what we are trying to do, and use that to simplify our analysis. Continuing on in play game, we have the question track, which then does a bunch of things that we'll get into in a moment. And then we change the computer's text, so the inner HTML of the computer paragraph, and we change it to computer message. So where it says, "Hi, how are you today?" that's the computer paragraph, and its contents will then be changed. And the final step is to take the human's input and clear it so that it's ready for the person to type in a new response. So after they've typed something in, the computer responds. We don't want them to have to hit the delete key a bunch of times to clear out that input field to be able to type in a new answer. Again, it's a nice to have in the form. Is it a must have? Sort of, but the program would work without it. From a programming logic flow, it's just not very usable at that point. Finally, we will have our switch statement, which is going through our question track. Now, the question track is really, we can almost think of it as the state of questions that we're asking. And we change that state or question track based on the answers that are being provided. So when the player provides a certain answer, then we are going to change our question track. So then we will ask questions that fit within the program flow or the logic that we've outlined in our flow chart that was created before we started writing the code. Now looking at play game, and we can see how play game, inside of play game in this function, it's calling other functions, but the core programming inside a play game has been broken into some very simple activities. We're changing the case, then we're doing our question analysis, and then we will take the message that was generated in one of those other functions and use that to update the computer's message and then wipe out the player's previous input. So play game has been broken into a few pretty simple tasks. And this question track here with the switch statement, it's allowing us to then separate out additional program logic and program flow from this function and put each element into its own function to better encapsulate our code, making it easier to maintain, easier to add to, and easier to read long term. If we are only asking one question, we don't need to add in these extra layers of complexity. But as this program is now going through a couple of different cases with these different analysis, it's starting to get a little bit complex. And if that's what's happening, it makes sense to break each chunk of like code into its own function. Now, it would be possible down the road we could do a further optimization that we really could have one analysis function, and then that function is then taking information from a matching array. So we just have a series of arrays. So we just have one function accessing the arrays that have possible words it's looking for matched to the question it wants to reply. So it would be a key value paired array. So we could further optimize this to create even cleaner code, but for where we're going right now, this will work. Though if you try and build, say, 100 different possibilities in your questioning, then this code is probably going to start to become unmanageable. And at that point, anytime when you're programming, if you realize it's starting to get unmanageable or overly repetitive, and if I look at this, it's starting to get kind of repetitive, that tells you that there's probably an optimization you could do programming-wise to reduce that repetitiveness. So you're doing dry programming, don't repeat yourself. And if you can do that, ultimately you will have better code. Now, the first thing that happens is if we look in our game, we will see that it starts out, question track is set equal to start. So the first time the script runs, and whether I click the button or press the enter key, key code 13, calls the play game function. When play game is called, the first question track will be start, and we'll see how that then will call the first analysis function. So when I go into first analysis, it's going to analyze the input from the player, and it looks to see, did their answer have the word good in it, or did the answer have the word bad in it? If it did not have one of those two words, it's going to then call the generic response function. And when it calls the generic response function, and we'll go back into the rest of that in just on first analysis in a moment. But in generic response function, then it checks to see if there are any generic responses left. If so, then it grabs it out of the generic response option, and then it removes whatever response was provided so it can't repeat that option. And it will then go through the generic response loop until there is nothing left in the generic response array, which in this case there's 3 of them. And once it's done those 3, then it's going to hide the button, hide the player input or human input, and it calls the endgame function, which after 2 seconds will then jump us to a new page. That is how our game ends itself. Once we land in generic response, it's a death spiral. We have 3 options, and then at the end of that, it terminates and goes to a new page. You can write a different ending. You can make it behave differently. You don't have to make it go to a new page. It was just an opportunity to introduce the concept of using JavaScript to navigate to a new page and using JavaScript to change the class that is assigned to a given element. Now back into first analysis, if when it analyzes the message, if it does not return a value of -1, that means it found the word good. So this says not equal to -1. So if it finds the word good, it will tell us what is the position in that string of characters, the number where that word good starts. So if it's the very first letter, it would return a value of 0. If it says I am good, so I space am space and then good would return a value of 5 since it starts counting at 0. But if it returns -1, that means nope, didn't see good. So then it says, hey, did you see bad? And if it returns -1, nope, there's no bad either, then it's generic response. But if it does return a number other than -1, it found it. And if it finds the word good, computer message will then be, I am happy for you, what is your favorite color? And it switches the question track to color. So if computer message has been updated, if we go back up here, we'll see the inner HTML, if the computer gets updated, human value gets wiped, and now it's ready for us to type in a new response. We type in a new response, and if I had chose color, now the next time through I type in a color, and then it is going to analyze color, because the case is now color, it's not start, it's color. So we go into color analysis, and in color analysis it looks for red and it looks for blue, and if it doesn't find either of those, it does generic response. We could extend this out and ask for a dozen different colors, so you could look for black, white, green, purple, orange, gray, yellow, teal, lavender, pink, chartreuse, periwinkle blue. So you could put whatever you want, and if you did do periwinkle blue, just blue would ping as correct because it would find the word blue in the answer. And if it did find the word blue, we can see it changes the message, and then it changes our question track to sad. So then the next time through, the player pushes the button or hits the enter key when it is under sad analysis, which has not been defined yet, but then it would try and do sad analysis. If I had chosen red as my color, then it chooses date as the analysis, which I don't know, only dog and cat and dog owner have been defined, so it's not going to be there. But if we go back to first analysis, if I didn't say good and had chose bad, then it goes into dog. Then based on the dog question, it says, do you like dogs? And if I say yes, then it goes into the question track of dog owner. If I said no, it goes into the question track of cat. And then under the question track of cat, it asked, are you a cat person? If you said yes, then it's going to go into color. If I said no, then it's going to go into the snake track. Now again, the snake track hasn't been defined yet. Snake isn't on my switch statement. So those things would need to be added in, but that's how we can start to build the logic to branch out our flowchart. So we have to think about which answer is going to lead us down to a new question track and what that question is going to be. And then on that track, what answers are we looking for? In all of the examples here, it's only looking for 2 answers, but there's nothing to stop you from looking for 3 or 4 answers. But it's hard to write a question that looks for more than 2 answers without it having a huge number of answers. Color is one of the few exceptions where you can somewhat predict a reasonable range of colors. If you were to even do 6, you would probably get most people. If you lead people with your question, it makes it easier to predict what answers to look for. And then once you find those answers, it leads you into a track, that leads you into an analysis. Once you run out of analysis, you can end it however you want, or you can lead it down into a generic response. You could have then an end response or some other thing that's not generic that's related to They went down a specific line of questioning, and now you lead them to an end. You take away the ability to keep playing longer, and you give them a final message to tell them whatever you wish to say.